Hello everyone, today we're going to look at a single population mean using what's called the student t-distribution. Whoops, don't know that's there. In the real world, we hardly ever know sigma. Why would we? If we do not know sigma, then we cannot use the normal distribution. Instead, we must use the student t-distribution. The student t-distribution is similar to the standard normal distribution in a lot of ways. The mean is 0, it is bell-shaped, and it's also symmetric about 0. Unlike the standard normal curve, the t-distribution is not unique. It depends on df, which is the degrees of freedom, which is n minus 1. Remember, n is the sample size, so the sample size minus 1 is the degrees of freedom. So here's an example of a couple different t-curves along with the standard normal curve. So the standard normal curve and the t-curve are indistinguishable if the degrees of freedom is infinity, which doesn't exist, right? You can't have infinity. But as soon as the degrees of freedom gets towards like 200, it's fairly close to being identical. So the higher the degrees of freedom, which means the higher the sample size, the more the t-curve looks like the normal curve. So again, they are both bell-curved, they both have mean 0, and they're both symmetric about 0. But as you can see, the t-curves with the degrees of freedom being smaller are shorter and fatter. And as the degrees of freedom gets higher, the curve also gets higher and skinnier until it gets closer and closer to the standard normal curve. To find things like the probability that t is less than or equal to t, using the t-distribution, we need either Excel or a t-table. Because there are an infinite number of t-distributions, we would, in theory, need an infinite number of t-tables. So sometimes you'll find t-tables with certain values of the degrees of freedom and certain values of the lowercase t. But again, because there are so many, it's not going to be very comprehensive. So we're not going to bother with the tables, we're only going to use Excel. So as a short little introduction, the command for Excel is t.dist t, df, 1 for the probability that t is less than or equal to t. We'll use similar commands to that of the standard normal curve for things like the probability that t is bigger than a number or the probability that t is between two numbers. So for now, you can either try to play around with it or just wait until class to actually get used to using Excel to find the t-values. You will have an Excel video after class for an in-depth tutorial though. So to find a 100 minus alpha confidence interval for a population mean without knowing sigma, we're going to use the following. It's going to be x bar plus or minus t sub alpha over 2 times s over the square root of n. So it's similar to the confidence interval if we know sigma, but instead of z sub alpha over 2, it's t sub alpha over 2. And s instead of sigma. So remember, s is the sample standard deviation, or the point estimate for sigma. Just as with the standard normal curve, we'll find t sub alpha over 2 using Excel, and the command, again, is very similar to the standard normal curve formula. It's t.inv, because again, it's the inverse. We're looking for the t value, not the probability. And again, just like with the normal curve, it's 1 minus alpha over 2, because we want the area to the left, not the area to the right. And then you also need to put in the degrees of freedom. We could also, due to symmetry, use negative t.inv of alpha over 2, df. So again, it's symmetric over 0. So whatever t sub alpha over 2 is, it's the negative of t sub 1 minus alpha over 2. Okay, so you can use symmetry there. Just don't forget that you're going to take off the negative sign. And again, we'll talk about this more in class using Excel. So we're just going to do some examples here for now. So suppose we want the 90% confidence interval from you if we know that x bar is 4, s is 12, and n is 36. So if n is 36, the degrees of freedom must be 35. So again, it's one less than the sample size. So we have our equation. We're going to plug in what we know so far. And then to find t sub 0.05, again, we'll use Excel. So if you want to try it out, you can. Otherwise, just bear with me for now. And again, we'll talk more about how to find it in class. But we should be getting that t sub 0.05 for degrees of freedom is 35 is 1.690. So I'm going to plug that in. 12 divided by root 36 is the 2. We simplify. And then we put it into at least somewhat of a sentence. The confidence interval is 0.62 to 7.38. So let's try another one. We do a survey of hypnotherapy to determine how effective it is in increasing the number of hours of sleep subjects get each night. Construct a 90% confidence interval for the mean number of hours slept for the population from which you took a sample of size 12 and found X bar was 8.942 hours and S is 1.405 hours. So we have a 90% confidence interval. That means alpha is 0.10. So we want t sub 0.05, half of that. And the degrees of freedom is 11 because n was 12. Using Excel, we're going to find that t sub 0.05 with the degrees of freedom being 11 is 1.796. So this is going to give us the confidence interval 8.942 plus or minus 1.796 times 1.405 over the square root of 12. Plug that into your calculator or into Excel, and that gives us 8.492 plus or minus 0.728. So we are 90% confident that the true mean of hours slept using hypnotherapy is somewhere between 8.214 and 9.67 hours. Which is good, right? Most people, you need 8 hours of sleep. So another example says a random sample of 20 students found that, on average, they spend 12 hours a week watching TV with S equaling 3.8 hours. Find a 97% confidence interval for the true mean of hours spent watching TV per week for the whole student population. So we're given S, so that means we have to use the student T distribution. So alpha is 0.03, so again, 100 minus the 97%. So we want half of that, which is 0.015. So T sub 0.015, degrees of freedom being 19. Again, we're going to plug that into Excel, and we get 2.346. So our confidence interval is this guy. When we simplify it, we get 12 plus or minus 1.993. So we're 97% confident that the true mean of hours spent watching TV is between 10.007 and 13.993 hours. As our last example, we have a sample of 25 pickpocket crimes, and we found the mean loss is $513.32, with S, the sample standard deviation, being $262.23. Find a 95% confidence interval for the true mean loss of all pickpocket crimes. Alpha is 0.05, so we want, again, half of that. So we want T sub 0.025 with 24 degrees of freedom. We plug that into Excel, we get 2.064. So our confidence interval is the following, except there's a rogue 3 in there. I don't know where that came from. So that 3 is not there. Ignore it. Should be 262.23. Again, that 3 is not there. So it gives us 513.32 plus or minus 108.24. Cross that out again. And we're 95% confident that the true mean loss due to pickpocketing is somewhere between $405.08 and $621.56. Okay, so again, if you don't feel confident using Excel yet for the T distribution, we will go over that in class. So you can just bypass that for now. Just make sure you know how to set up the confidence interval. Okay, so let me know if you have any questions. Thanks.